In this video, I am going to show you how to find slope at the point of a beam using moment area method. And this is the example 3 problem. So you can see beam here. Determine the slope at point C of the beam in figure. E and I are given. A is a pin support and B is a rocker support. At middle of the beam you can see there is a point load of 20 kilonewton and all the lengths are given in this figure, and we have to find the slope of this C point. So our first step is to find its support reaction. So at A there is a pin support, therefore we have to mark two force components, one horizontal force component and one vertical force component. At B there is a rocker support, therefore we mark one vertical force component. Next I am going to find this AX force. For that I will take sum of all the horizontal forces. So if I take horizontal forces, I will have AX equals 0 because there are no other horizontal forces in this system. So next I will remove this force because no point of marking this AX force. So next I will consider sum of all the vertical forces. So if I consider vertical forces, I will have AY plus BY equals 20 kilonewton. And if you closely look at this diagram, you can see there is a symmetricity of this beam. So you can see middle of the beam there is a point load and there is a vertical force at A. B also there is a vertical force. So that means this is a symmetric structure or symmetric beam. Therefore I can say AY equals 10 kilonewton and BY equals 10 kilonewton. Those are simple calculations. In moment area method, we have to draw bending moment diagram. Then we have to draw M over EI diagram. So next I am going to draw bending moment diagram for this beam. For that I have to divide this beam into two parts like this. So I will cut this beam through a random point like this and mark this distance as x1, right? So next I will draw this small part alone. So you can see the part of the beam. I mark the distance as x1 and this is the support reaction at A, and this is the shear force, it marked as V1, and M1 is the bending moment, and I mark this point as P. So next I am going to find this M1, and this is the range. This x1 is valid for this range 0 to 6. So beyond 6 I can't apply equation which I get from these calculations. So I am going to take moment about point P to the counterclockwise direction. When I take moments, I will have m1 minus 10 x1 equals 0. So it comes m1 equals 10 x1. So this is y equals mx type. So that means I can draw bending moment diagram here for this AD part. It's like this. So this is y equals mx shape, and value of this point can be found substituting x equals 6 to this equation. So then I will have this point bending moment is 60 kilonewton meters. Since we have to find slope at C, we have to find moment at this point, which is distance of 3 meters. So for that I have to substitute x equals 3 or x1 equals 3 into this equation. So when I substitute it, I will have 30 kilonewton meters. So 30 kilonewton meters is the bending moment value of this point C. So that is the AD part. Next I will draw bending moment diagram for this DB part. For that I will cut this beam through this point, this random point between D and B. So then I will mark this distance as x2. Next I will draw this part of beam in next page. Here you can see I marked here distance as x2. This 6 meters is the distance to point A to this point load, and I marked this point as q, and m2 is the bending moment. So range is 6 to 12. So equation we will get from this calculation can't apply for less than 6. So this is valid for this range 6 to 12, which is this range. So next I am going to take moment about point Q. Then I will have m2 plus 20 times x2 minus 6 minus 10 times x2 equals 0. Then I can simplify this and get an answer for m2. m2 equals minus 10x2 plus 120. So as you can see, this is y equals minus mx plus c type. So in order to find the value of this point means this point D, you have to substitute x2 equals 6. So when you substitute x2 equals 6, you will have m2 equals 60. Then in order to find value of point B, you can substitute x2 equals 12. So when you substitute x2 equals 12 to this equation, you will have m2 equals 0. So that diagram will be like this. So next I will show you completely drawn bending moment diagram for this AB beam. So this is the bending moment diagram. You can see maximum value is 60 and bending moment value of point C is 30 kilonewton meters. So this is the bending moment diagram. But in moment area method, we have to draw M over EI diagram. So it's simple. Once we got bending moment diagram, we just have to divide values from EI. So next I will show you how I draw M over EI diagram for this beam. So this is the M over EI diagram. So it's simple. We just have to divide values from E and I. Next task is to applying this moment area theorem. So first I will explain this diagram. So you can see this blue line, right? So you can see this blue line, it's the deflected shape of this AB beam. When this beam is deflected, it will be like this. And you can see point A here, and this is point B. Middle of the beam I marked as D. So since this is a symmetric structure, when I draw a tangent line at D, it will be a horizontal line. So you can see I wrote it here horizontal because if I draw a tangent line at D, it will be a horizontal line, and I mark it as tan D. So that is the tangent at D. So we have to find slope of point C. Therefore, we have to draw a tangent line at C. So this is that line, right? I marked it as tan C. And here you can see I marked the theta C, that is the slope of point C. I marked it as theta C. And here I mark angle which is theta D respect to C. I mark this angle from tan C. So that means this is theta D because this is a tan D line, this is tan C line. I measured this angle from tan C to tan D. Therefore, I can write this as theta D respect to C, or we can just say theta DC. So that is the notations of this diagram. Since tan D is a horizontal line, I can say theta DC is equals to theta C, which is slope of point C. So that means if we find theta DC, we will have theta C. So next I am going to find theta DC. So using moment area method, I can easily find this theta DC. Okay, you can read the theorem 1 here. You know there are two theorems in moment area method. So in order to find slope, we have to find theorem 1. In order to find deflections, we have to use theorem 2. So they are asking slope. Therefore, we have to use theorem 1 of moment area method. So you can see I wrote here theta C equals theta DC. So there are two letters now, D and C. So now we can go over M over EI diagram. So we have to mark area between D and C. So this is C, this is D. Area between D and C, or area between C and D, is this area. Now we just have to find this area. So that is the answer. That is the slope at point C. So for that I will draw a line through this point. Next I can find this area easily. So it is a rectangle. So its area is 3. 3 is this length times this height is 30 over EI. Next I will find this area. It is a triangle. So its area equals to half times this length. It is 3 times this length. So this length is 60 minus 30 over EI. Next, I just have to get the sum of these two. So I will show you clearly wrote equation. Here you can see theta c equals theta dc equals 3 times 30 plus half times 3 times 60 minus 30 over EI. So you can see this height is 60 minus 30. This is the area of this rectangle. And this is the area of this triangle. So when you simplify it, you will have 135 over EI. So next you can substitute values for E and I. Then you will have theta c is equals 0.112 radians. Please like, comment and share this video. To watch future educational videos, please subscribe Educate Today YouTube channel. Thank you.